Hello everyone, and welcome to the instruction video to Seamless. Seamless is a framework to build cells that react to each other. This is a bit like a spreadsheet, like Microsoft Excel. For example, here I set up a very simple Seamless context consisting of a cell A and a cell B and a result cell and a formula that says that the result should be equal to A plus B. So when I change A, you see the result update. Same when I change B, and likewise I can change the formula. So now it's A times B, or B minus A. And like in a spreadsheet, you can adapt these formulas and see the reaction happening live. Now, because the cell contains Python code, you can do in a cell everything that Python can do. For example, here's some Python code for the Fibonacci series. It computes the Fibonacci series for A plus the Fibonacci series for B. You can do it like this, or you could import some math library that does it for you. So with this, you can still modify your parameters and see the effect, and you can modify the algorithm and play with it and see the results live. In addition, in Seamless, everything is a cell, and then I mean everything. Also the code to visualize this cell and to edit it. It's itself a cell. I have the source code in here, and so for example, if you think that these letters are a bit too small, you can make them a bit bigger, like that. If you want them in red, you can just set the color to this. If you prefer blue, like that, and set the font to italic. And I am Dutch, so one might want to have this in my own language. And I got something like this, and change the shortcut, and then I can modify things like that. So everything is live and remains functional all the time. You can change values in the input data or the formula, and while you edit the text, and get a live feedback loop. So while you can use spreadsheets for simple formulas and plotting, you can definitely do that with Seamless too, but you can use also Seamless for developing algorithms or OpenGL shaders. And if, for example, you connect the output of one transformer to the input of another transformer, you can create all kinds of workflows. So right now Seamless is already quite powerful, but compared to a spreadsheet, it's not yet very convenient. In a future version of Seamless, there will be GUIs to set up this kind of relations between cells. That result depends on A and B. But for now, you have to set up things yourself in IPython. So I'm going to show you how to do that for the current version. So first you have to install Seamless. And you go to a terminal and you have to type pip install Seamless framework. Seamless is a Python 3 library, so you may have to type pip3 in front. And if you're on Linux like me, you have to type sudo and give your password, and then Seamless will be installed along with some dependencies. Most important one is PyQt5. It's maybe some difficulty to set it up on your system, depending on where you are. The other dependencies like NumPy, PyOpenGL, and the other ones, they are quite easy to set up. The installer will do it all by itself. So once you have Seamless installed, you can then use it from IPython. So for example, from the Jupyter notebook, like this. I assume you have some experience with that. So let's import Seamless. So the most important thing in Seamless is the cell. Cells are organized into contexts. So let's import from Seamless cell and context, and set up a default context called CTX. Now let's create a few cells. Let's go to the cell called A, which is an integer. Give it the initial value, let's say 2, and another one B for 3, and another result cell, another integer cell, which is the result cell. Now then they are all being created. So in a spreadsheet you would write the formula for the result directly inside of the result cell. In Seamless it's not like that. You put it in a separate cell, a code cell, which normally contains Python code. Let's import a code cell. And let's call create one called formula. And give it the initial value, return A plus B, like that. Now to actually perform the computation, we have to set up a transformer. A transformer has a number of pins, input pins, and an output pin, and then it performs a computation on the cells that are connected to the input pins. So let's import a transformer. And create one. Let's call it transform. So we have to declare all of our pins. A, which is a input pin. Integer. Same for B. And same for the results, except that result is an output. Just like that. And now you see that the transformer, let's call it T, has pins called T.A, T.B, and T.results. All of them input pins, output pins. In addition, it has one additional input pin which is called code. Every transformer has one, and that should contain the Python code. So to activate the transformer, we have now to connect the cells to the input pins. So you always do it cell point connect to input pin, like this, ctx.a dot connect to A, ctx.b dot connect to B, and for the result it goes the other way around. We take the results output pin and we connect it to ctx.results, like that. So in principle the result should now contain the value of the computation, but it doesn't. So something went wrong. So let's see what we do status, and then we see the result is undefined. Well, we knew that already, but you also see we forgot to connect the code pin. So let's do that. Let's take the formula cell we had before and connect it to the code pin. There you go. Now the status should be OK. And now the results should be in here. And there it is, 5. And now the result will respond in changes to A. For example, like this. To B, and now you see that result.value is equal to 7. Likewise, it will respond to changes in the formula. see here is now 2 times 5 is 10. Now I have to admit that setting up a transformer like this manually is a lot of work. It's less convenient than a spreadsheet where all of these relations have already been defined. Now a future version of Seamless will definitely contain a GUI where you can define these things by point and click. In the meantime, if you have some programming expertise, you can already define up some convenience functions. For example, I defined this one. It's a function called makeTransformer, and you just give the types and the names of your arguments and which one is output, and it will create a transformer for you with this. So let's call it transform2 is makeTransformer. You can integer a, integer b, integer result 2. We say that the output is equal to result 2, and that the code cell is equal to, well, formula 2. Now we have a lot of new cells defined. Formula 2 is now here, and result 2 is now here. And as soon as we set formula 2, so 2 times a plus b, something like that, and then we can print the result of value of result 2, and you see it's 12. So this kind of convenience functions can be quite handy as long as your name of your pins is the same as the name of your cells, which is nice. It's okay in a small context, but it's like as if you are in Python making all your variables global. It's convenient, but if you make something larger, you really should use function parameters to define your variable names. Convenience is already provided by the GUIs in the Seamless library, in particular the ones to edit and to display cells. Import, edit, and display. For example, let's create a small subcontext to organize our cells a bit better, and then we do is edit ctx.a. We create a little window to edit cell A, and another one for cell B, and to display the results, another window. So then we have the windows that were, well, you already saw before. Window for input A, and for input B, and for the result. And now the result reacts to the inputs like that. And likewise we can create one for the formula. This will be a text editor, and there it is. It's a bit big. And for the text editor you have to press Ctrl S or click on save to make it work. And like I said, in Seamless everything is a cell. So in fact, if you look at what is actually created by this edit function, so this is actually a Seamless context. And inside the context is a reactor. Seamless has two classes that perform computations that react to cells. one is the transformer and one is the reactor. They work almost the same. For both you have to declare input pins and output pins and then connect cells to it. But where a transformer can have only one output, a reactor can have multiple outputs. And where a transformer has only one input pin, a reactor has three: code start, code update, and code stop. Now let's create our own reactor. And let's create 3 Python cells that will contain their code start and code update and code stop. And let's create a reactor that just reacts to the value of A. So again we have to define pins, but now we're going to just define one. Inputs, and the d-type is equal to int, and then we can connect now x.a to reactor.a. Oops. And now we have to set values for all of the code cells. So for code start we say, let's say print start. And we set the value, let's say some value to 42. For code update, we print update, and we print some value. And for code stop we don't do anything. Like this. If you look at the status, we have to still connect them to the reactor. For code start, update, for code stop, and then you see that start is printed out and then update 42. Whenever you start the reactor, first code start is executed and then code update. And you see that code update has access to the variables some value, its value 42, that code start has just defined. In addition, the code cells also have access to the input pins and the output pins. They are in an object called pins with all capitals. So here is some new code for code start and code update that uses that. The code start just sets a value to the initial value of A, and then this value can be accessed by code update. It again checks the value of A. If this value is set for the first time, which is just checked here, then it prints a setting value. And else, if code update was invoked by an update of A rather than by the start, it reports that update has now been updated. So here you see an error message but it is actually harmless. So if you look at the status, the seamless status is actually okay, because what happened is the code start, it got updated with this new value of the code, then it tries to execute the update with the old value, which gives an error, and only once the new update cell has been defined, then the code start and the code update, they are both in the correct state, and then the error message essentially disappears because you see that here the status is okay. So this kind of glitchy behavior, it's actually the same as a spreadsheet. If you want to change the formula to refer to a different cell, you have not defined that cell yet, you will get first some kind of undefined error, and then when you fix it, it's all gone. And you see here setting value to 8. If you now, we still have the GUI. So if we change here the characters 7 towards 8, 6 or 7, 5 or 6. And now you see that the reactor, it reacts to any updates in A. So going back to the GUI, we saw that ctx.gui.formula.rc is in fact a reactor, and this reactor does the text editing of the formula cell. The code cells that are connected to the reactor's code input pins, code start, code update, etc., they contain the source code of the text editor. Now let's have a look. So this will get you to give the code start pin, this will get the associated cell, this will get the value, and there you see the source code, and we can edit it also. So let's do it to GUI. So it's essentially the source code of the text editor. So here's again the text editor window that you saw at the beginning, and you can change the font of the text editor, the font size, the color, whatever you want. It's a nice way to learn PyQt, and once you know a bit of PyQt, you can create an improved text editor, because this one's not very good. And if you then create a pull request on GitHub, I will be happy to include it in Seamless. For example, you could try to add syntax highlighting to the editor. In the notebook version of this tutorial, there is a bit of code that could do this for Python syntax. Or you could try to implement tab completion. But in the meantime, you probably don't want to use this text editor to edit text cells. Instead, you can link the text cell with Seamless onto a file on the hard disk. So let's do that. Let's take the formula cell and define a directory. Since I'm on Linux, I use tmp. I'll call it formula.py. And if I would go to a terminal, so here it's written a plus b, and now you can put both editors side by side, and what the link does, it synchronizes the contents of the cell to the file, like that. And likewise, the contents of the file are synchronized to the cell. So that was the end of the introduction tutorial. In the next tutorial, we will create text cells to describe OpenGL shaders and see the result live.